Quick bit of information before we jump into all of this stuff here today. So, legal department gave me a heads up. Apparently the term engineer and professional engineer are now interchangeable when it comes to, well, as it comes to legalities. I am not a professional engineer, and in some countries I'm not an engineer at all. So why should you listen to me? Well, I happen to use a power chair every day. I happen to have an entire small building here filled with over 20 something different power chairs. I've seen a lot of problems with them. I've come up with a lot of solutions. I've seen a number of trends, and also with YouTube and everything here, I have quite a bit of contact information with a lot of people all over the world, and everyone likes to share their experiences. So I'm kind of a central point where I hear a lot of things from a lot of different places. But I don't have my papers. I don't have my certificate right now. I have worked engineering jobs in the past. I have worked in destructive testing, done all kinds of that, but that's really irrelevant. I'm not an engineer, not a professional engineer, not pretending to be one. I'm just average Joe who has a lot of crap in a little windowless building, and I tend to notice things. And I attempt to distill it down into a way that makes sense to anyone who cares to listen. So with all that in mind, we're gonna take a look at this version 1 4front 1 and also compare it to the Edge 3 Stretto over there. And I have a lot of thoughts. I've run across a lot of interesting things with it, and everything in this video is an opinion. So take that as it will. I unfortunately have to say things like this because, you know, the internet's what it is and lawyers exist and all that stuff. So anyways, hopefully you enjoy. Here's some information about the Quantum 4fronts that I've owned, one that I currently own, and a little bit of information from other people that currently own them. Enjoy. Quick side note about the intro. Stretto Edge 3, the fender lighting controller broke the chair and made it think it was charging when it wasn't, and it wouldn't move, so we had to unhook that. This has the same fender lights, so I thought, oh, we can take the switch off of that and put it on this. Nah, these don't work either. At least the chair turns on and off though. Usually. Yeah, here we are at the warehouse once again. Today I'm actually kind of excited. We're going to talk about the 4front here again. I've already taken a bunch of the plastics off of it, but in case you're wondering, it's the purple one. It's the 4front 1. So on the live stream last week, or was it this week? I don't know, whatever. The last live stream, we kind of looked at this thing on how to defeat the traction control. Now, today we're going to take this thing apart. I'm going to show you a bunch of interesting things I've discovered about the design and some other strange things, whatever. But I want to say up front, you cannot simply defeat the traction control on this chair. Because it's a front wheel drive, there's a bit of a physics problem. The back wheels are always going to try and get around in front of you because of the way trailing castor works and just, like I said, physics in general. So a chair that's front wheel drive that goes over about 4 to 5 miles an hour has to have some sort of stabilization. Whether it's a gyro, whether it's these stupid castor angle control sensors, which they've since stopped using on the new version. But regardless, you have to have something. After the live stream, when we figured out it was really easy to take the magnets out of there, and I'll link to that live stream, I think it's up there and down below, with some timestamps and whatnot. But after we figured out all you have to do is unscrew the little magnets from the sensors, we were done with the live stream, I hopped in and I was running around the warehouse. I could not get from here to the front door and back without the thing being uncontrollable in a way that resulted in me knocking over a bunch of stuff. And then I realized, oh, this is front wheel drive and it goes more than 4 or 5 miles an hour. So anyways, wanted to say that up front. As far as defeating the traction control, haven't figured out a way of doing it yet. So unfortunately, those traction control slowdown errors are kind of part of life for right now. But that being said, we're gonna look at a few other things on this. I started taking it apart the other day and I realized I needed to stop and then film it because there's a lot of interesting design choices. So I'm gonna gather some of my tools, we're gonna hop down on the floor here, and we're gonna start by taking apart the rear on the rear castor arms, the swivel bearings that allow the wheels to rotate as you move around. They made some really interesting design decisions. Here we are behind this thing. This chair, I forget what year it's built, but it's the version 1 of the 4front. They did a couple of different versions, but this thing has about 1,300 miles on it. You can see we've got a little bit of play in the drive units or motors or whatever. Moves back and forth just a little bit, not too incredibly bad. Now, I'm going to use the term drive units here because, well, it's a term that Permobil uses, but also the gearboxes and the motors are basically all one unit. Yes, they do disconnect, but you can't buy the parts separately. So when I say drive unit, I'm referring to the motor and the gearbox. These are actually very similar to Permobil style. I have not taken apart the gearbox on one of these yet. We will at some point, not today. But these use the same type of setup where there's one giant gear inside there and then a worm drive that comes out and twists on that. So, well, I'm assuming. The way they're shaped, they look exactly like that, and that's what's inside Permobil motors. I think that was vlog number 333. I'll link that up here and down below so you can see what the inside of those look like. But that's kind of how these things are set up. So it's a little bit odd that we have any play at all. And actually, a lot of that's probably from the brakes, because we know that these motors here, these are what I call the brown motors. They're sort of I guess these ones are black. They had another version on the Edge 2s that were more of a brown color. But from my original 4front, we knew that the brakes were pretty inferior on these things. And also the way the brakes attach to the output shaft of the motor left quite a bit to be desired. And you can kind of hear that noise here, that metal clicking. They had a couple different versions of these motors as well, in the sense that the coupling between the brake and the motor used a couple different methods. One was a keyed output shaft with a nut over the top of it and a circlip. Those are the ones that rattle. I'm assuming that's what's in here. Another version actually had a set screw that held it in place. But anyways, 1,300 miles on this thing. I have no idea the service history on this, but we're going to start by taking apart these castor swivel stems here. I've already taken apart that side, but this side I saved so we can do this together. We're going to start here by jamming our low-profile Harbor Freight aluminum jack under this thing and lifting it up just a little bit. And I've already removed all the plastics. There's covers and everything that normally go over all of this. There we go. Don't need to get it off the ground very far. So what we're looking at here is the castor swivel bearings. It's what allows this wheel to do this. Now, different brands do the anti-flutter differently. Permobil, for example, used to use just a double set of O-rings that caused some friction inside this tube. Those would wear out eventually and you had to replace them. They went to another version that was kind of O-ring, but it was adjustable. They only used that for a couple of years. And now they actually use a version that has some spring washers and friction clutches in them. Those are problematic, and we're also working on making replacements for those that take care of it. This system is completely different. Regardless, on any chair, to set the amount of tension here, assuming it's adjustable, the way you measure it is by jacking the chair up off the ground. And this is going to seem really weird and counterintuitive and have a bunch of variables. But what you do is you take the wheel and you just flip it like this. And you want it to rotate under 1 revolution after you let go. Now you might think, how is that a scientific way of doing this? Because who knows how hard you're pushing it? I'm pushing it here at different rates, but you just kind of give it a flick. If I go really hard, it goes around once. But regardless, the weight of the whole system and the amount of friction that's in here and everything, just giving it a pretty good shove, it should go no more than 1 revolution. I'll show you on the other side here. This side does not have the proper tension. We're going to get into that later, and we're actually going to have to replace some parts to fix this, but check it out. Same amount of push. It goes around like twice. So that is too loose, and this is going to result in castor flutter at speed. You can see how almost no force, and that thing just moves. Switching back to this side, you can see that just lightly tapping it, it almost immediately stops. And then giving it a good shove, it doesn't go all the way around once. Okay, let's get this taken apart, and I want to show you the design decisions that they made in here. It's super interesting. I still haven't figured out if this chair is metric or standard, but this is a 3mm metric Allen. And we got to pull out all 4 bolts so we can remove this castor angle sensor here. Now, just so you know, anytime you remove this, there is potential of these things losing their calibration. And that requires a dealer or a rep or a DME or something like that that has an unlocked QLogic 3 programmer to go in here and recalibrate it. So in theory, you can take this off and put it back on as long as you don't change anything inside here. And I'll show you in a minute why that is. But just be warned that if you try to take this apart, there's a very high likelihood that when you put it all back together, your chair is gonna throw constant traction control errors, and you're not gonna be able to drive this thing over 1 mile an hour. So just a little flat sensor here. It's got sort of a rubber coating. I'll just pull these screws out. But this is essentially a Hall effect sensor, and they've got their CAN communication all built into this module. So this plugs in with a regular bus cable. Of course I didn't bring my lights with me, but this plugs in with a regular bus cable to the multiplexer or whatever that thing is back here, the splitter for the bus system. So anyway, so we're gonna pull this to the side. And then if you notice here, there is what appears to be a little magnet on top of the castor stem. This is what we discovered in the live stream. Well, one of the two methods. You can just pull this off and stuff it down here, put all the plastics back on, and you won't get any traction control errors. Or you can unscrew this little magnet, maybe. Okay, that one's in there pretty tight. Okay, I can't get that one off, so I'm gonna use pliers. Now, we're crossing over into the point here to where the second I adjust this magnet in relation to how this wheel moves and put it back together, it's gonna require recalibration. So I'm just gonna lightly grip the sides of this little piece. Man, they must have used thread sealant on this. The other side came right out. I wonder if this is cross-threaded or something. This isn't 100% necessary to remove if you're gonna be servicing these components in here. But once again, I'll explain in a bit the issues with this setup. So it's basically a little neodymium, I always say, but it's a little rare earth magnet in here on this little machined puck with some threads. And that goes right in top of the bolt that goes through and holds this whole thing on. So this thing basically rotates underneath this sensor with the, North Pole, South Pole magnetic fields. And this is what the chair uses to detect the angle of these rear casters, and can also cause a bunch of errors. They could have made this system work better, but I think they rushed the software algorithms and the sensing. I'm just gonna put that right there. I think they rushed it too much basically, and the software just wasn't ready for production. And maybe there's some other limitations I don't know about, but on the 4front 2, they actually do not use these anymore. So that tells me there was some inherent issue with them making it work properly. And they basically admitted that they knew there was issues with this chair, and in their own words, they needed to do better. I have a clip of that. If I can find it, I'll put it in the video.
We learned a lot on our 4front 1. We learned a lot of things that we needed to do better. And
I get to looking around down in here, and well, I noticed there's a bit of rust, debris, and a bunch of dirt down here. And that side, the tension, like I said earlier, was not correct. This side was. So I figured we need to take it apart and see what's going on in here, maybe clean some stuff. This nut that's in here, what size is this? Appears to be 3/4 inch. This is like an impact drive socket. It's the only one I had that was large enough to go in there. When you take these apart though, you want to make sure that you're supporting the bottom of this, because as soon as this top nut comes out of here, there's a lot of parts in here that are gonna go flying. So I'm gonna hold the bottom of this wheel with one hand, and then we're gonna loosen this up. I've got my foot kind of over here to keep this from rotating. And these are nylocks, so they usually take a little bit of force. Okay, that's loose. So we have a nut here on the top, just sort of a standard-ish 3/4 inch nylock. Then if we look down in here, we can see what appears to be some washers and stuff like that. So I'm gonna carefully pull this whole thing straight down, and you'll immediately see something that is not common on any other wheelchair I've seen. Look at this. We have Timken tapered roller bearings. I have never encountered any wheelchair that uses bearings like this. Now, in the grand scheme of things, as far as design goes, this is a very robust and strong way of doing it that can last a long time. What most manufacturers do is use sealed roller bearings that are in an entire package and they just slide over the top and call it a day. They're sealed, you never have to service them, occasionally replace them. These things, however, are like what the wheel bearings are on your car. So very strong, can be very long life. However, they're not sealed and there's no weather seal underneath here or keeping water and stuff out. You can see here we've got some rust and other debris on the top of this thing. So for longevity, this is a really good decision, but in a wheelchair, I probably wouldn't use it because this is gonna have to be serviced depending on, you know, whether you're running around in parking lots in the rain or in a lot of dust and dirt. These are gonna have to be serviced every 6 to 8 months. Taken apart, maybe replaced, but just cleaned and greased. Since there's no weather seals in here, nothing keeps the water out other than the grease that's in here. So, pretty interesting. I like it, but at the same time, yeah, kind of a strange decision. Let's keep going here. We're gonna pull the rest of the assembly out of here. There's a whole stack of stuff. It's hard to get it all in one. Uh-oh. Okay, there we go. Whoop. Okay, see all the rust? This little stack right here contains an actual proper thrust bearing. So as you can see, this thing is all, whoops, dang it. We lost a couple of the needle bearings. Oh, they're right here on the floor. As you can see though, these things haven't been serviced and they are all rusty. So again, as far as longevity and strength, really good design choice, but on a wheelchair, not what I would do. Simply because, well, who are you going to get to take this apart and service it? You can see here we've got a few of the needle bearings that have fallen out of this. There's a center spacer here that everything goes around, and then we have 2 spring washers. These are the conical, kind of cone-shaped ones, and these are what set the tension on the caster arm swivel. Now you might be wondering here, Dan, you said these are really good components that are designed for a long service life. Why are they something you don't want to use in a wheelchair? Well, here's the main problem. You cannot buy these parts from Quantum. They don't sell them. The only way you can get a service kit for these bearings is to replace this entire arm with the forks. The wheel might be separate, but you have to buy the entire arm with the forks and all of this as one assembly. That kind of blows my mind. Here's the other problem. We've got the little magnets in here, right? Now that I've taken this out, let's say I sourced these parts and I want to replace them because obviously, I mean, look at this bearing. This thrust bearing is basically hosed. We're gonna try and clean it up and get it back together so the chair is functional, but that needs to be replaced, as do these bearing races. Luckily these are double-sided, so I'm gonna get some sandpaper, we're gonna try and clean these up, and we are gonna put it back together and reuse it. But now that this is all taken apart, our sensor's off, our magnet is in my hand, if I get these parts and put it all back together, this chair's not gonna work, because it has to be connected to a programmer, and these sensors are gonna have to be recalibrated. I have no idea if that was intentional. It's probably just a side effect of the way this works and how it was designed, but unintended consequence. This is like Apple or Samsung or someone pairing their battery electronically with the phone or the headphone jack or the home button. You can buy the parts, but it won't work. I mean, again, I don't think this was intentional, but it was just kind of a byproduct. Yeah, what is that? This magnet basically screws right onto the end of this bolt here. So you can see there, that's our magnet that those sensors use, and that screws in there. In theory, you could leave this magnet attached as you drop everything out of there. All these parts, however, are ferrous metal, which means magnets are going to stick to them. So trying to pull that out is going to be a huge pain. I think what someone could do if they were able to get these parts was after you take this nut out, leave the socket in here and press down on it, and that will hold all of these components that are stacked together inside here. So you just put a little bit of pressure on this, and then as you pull the wheel out, it'll keep everything in there. I think that might be a way around it, because again, I don't recommend doing it because this could make your chair not work. But if this never comes off of this stem and you put everything back together and then you reassemble it and drop the sensor back on top, you might be able to keep the calibration, maybe. So, yeah. My thought here was, I can just source all these parts, which I'm still going to do, but I can source all these parts and sell a service kit. Because if you keep this stuff greased and cleaned, you're gonna be fine. If for some reason you go a little bit too long and they get damaged like this and you need to replace them, not being able to buy the parts is like, well, kinda. So my thought was, I'm gonna source these parts, I'm gonna measure them, I'm gonna figure out where they can be purchased, and the plan will be to get them up onto the website, with the caveat that replacing them might make your chair stop working. Using the socket to hold everything in there, I think it should be okay, but yeah, really frustrating. Seeing as how I need to put this chair back together and I haven't yet been able to source these parts, we need to get this cleaned up and put back together. We've got the thrust bearing here, which I think you can see is missing. Yeah, you can see those holes. We're missing, 4 of the needle bearings. We have 3 of them right here. Let me dig around in here and see if we can find the 4th one. Well, regardless, we're going to clean this up. And to do that, we're going to use everyone's favorite libation, WD-40. And we're just going to go ahead and hose this. Why is this not spraying? There we go. We're going to hose this down and apparently make a mess on the floor here. Yeah, great. It's going to be all slippery and nasty in here now. We're just trying to get the rust off of this stuff right now. So I'm just going to spray all this down. There we go. Let it soak for a little bit and see if we can get this cleaned up. Uh-oh. This is part of a bushing. So there's supposed to be a bushing down in here. Yeah, that's half of a broken bushing. There, you can kind of see between my finger and the side there, that little white piece. That's the rest of that little bushing. Obviously the top half of that's not supposed to break off, and the piece that's still in there is intact. So we're gonna load everything back in there and hopefully at least get it functional. This roller bearing here seems to be in pretty good shape. It's still got a bit of grease on it. You can see the green there. There's a lot of dirt, obviously, but oh yeah, there's all kinds of chunks in there. I'm gonna get this cleaned up and force all that grease out of there. Then we're gonna reassemble everything with some white lithium grease. This is not the long-term solution. It's the only thing I happen to have here. It will work fine for these bearings, but it won't last as long as regular bearing grease. So just in the interest of, you know, getting this thing back together, we're gonna use this when we reassemble it. But I'm gonna go ahead and get all this stuff cleaned up. Then I'll be back in a few minutes once we're ready to reassemble. Yeah, look at that. You can see where all the needle bearings are supposed to be rolling on there. Yeah, I would love to be able to find these parts and, you know, source a kit that I could sell so people can replace all this. But let's see if this is pressed on here, even if we can get this thing off. Because requiring a machine shop to repair your chair is also less than ideal. But this might be pressed onto this shaft. Yeah, there's no bolt pass-through on the bottom there, so it's not just something you can unbolt. This stem is part of this fork assembly. Yeah, this is pressed on here. There's a little bit of a metal lip down here. You can see right there that it rides on, so you can't really get anything under there to pry on it, or even get a bearing puller on there. So I'm not going to commit to finding and sourcing these parts, simply because if I do that, it's going to result in a bunch of people with uncalibrated chairs that have to go in for service anyways. And there's quite a few dealers and DMEs that don't understand how that calibration works. And also, Quantum does not make the tools or the programmers available to a lot of dealers to do that anyways. So, good times. Okay, I was able to use some sandpaper. It's off of some power tool, but I was able to use that to knock down a lot of the rough surfaces on these thrust bearing races. So I think we should be okay to put these back together. I'm going to get a little bit of the white lithium grease here, and we're going to squeeze just a little bit of that here onto this thing. White lithium grease goes pretty far, so it doesn't really take a whole lot. So I'm just going to kind of wipe that around here. Okay, there we go. We'll set our little needle bearing cage back on here. Set that whole thing down. Then the top race, we'll do the same thing. And now we have a weird little bearing sandwich. And I just lost one of the needle bearings. Oh. And we've got this bearing all nice and cleaned out. Same thing here. We're gonna work in a bit of the white lithium grease. This is kind of a messy thing though. And you basically work it in here, rotate the thing around, get it forced into all the little rollers, and then wipe off all the excess when you're done. But there's a bit of space behind the cage where these bearings roll around, and you got to get the grease all down in there too. I like to push it down from the top and kind of get it behind, then rotate it around. All the rollers pick it up. Looks like our SD card is full. Hang on a second. Of course, my fingers are all nasty now. Alright, one fresh SD card later. Continue kind of packing this in here. And actually, if you see, there's still a bit of rusty debris. As I rotate this around, you can see kind of some discoloration on these little wheels. I am going to be taking this apart again in the not too distant future, because we need to measure all this stuff, and I do want to replace all this. So once again, white lithium grease is not the choice for this for long term, but for now, it'll at least get our chair back on the line. That's mostly what I'm concerned with at the moment. Oh, I didn't check. There's a bearing race underneath here too. Hang on. Yeah, there's our bearing race right here. I still need to clean that up. And you can see the little piece of the bushing, that sort of off-white yellow thing in there. So let's clean this up here just a little bit. Yeah, bit of filth in there. And the problem is too, so once again, like I said, it may not have been intentional that you have to replace this whole thing, but that bearing race has to be pressed in there and removed as well. And there may not be a reasonable way to do that, which could be why you got to buy this entire arm. So, I don't know. You know, people have copays, and maintenance on consumable items with typical warranties are not covered. This is a maintenance item. So if you're going in every 6 months to do this, one, your insurance might be like, what are you doing? You're not supposed to do that since this is a non-standard setup. I mean, who puts freaking tapered roller bearings in a wheelchair? Again, good idea, but not for a wheelchair. So I don't know. It's, so many mixed messages here. Okay, that seems to be reasonably packed. I'm just going to wipe up a little bit of grease here that's on the bottom of this. There we go. Oh, and then there's this little piece right here. This goes on over the threads. And all of the components, like these stack of spring washers, yeah, see how that magnet makes this impossible? But that goes on around all these spring washers and through the middle of our thrust bearing stack to, actually I'm going to unscrew that magnet. But it goes on over that, and that's what centers everything up in here. I'm going to see if I can mount the camera in a different spot so you guys can actually look down there. That's about as good as I can do with the tools at my disposal. So we're going to stick this piece of broken bushing in there. Then, with our little collar on here, we're going to load this up through the bottom. And then use this Allen wrench. Where'd it go? Actually, yeah. I'm going to use this Allen wrench to kind of push that down into place. There we go. Then we're going to drop our stack of thrust bearing in here. And hopefully that all stays together. Get that around the edge of that center spacer. There we go. You can see, I think you can see, that it's turning in there now as I push on it. So that should be good. Oh. It's hard to hold this in place while I do everything. Okay, that's good. Then we have our two spring washers, which are concave. They need to have the open faces facing together, like that. Sorry, it's kind of blown out. So we'll drop these both down in here. There we go. Then we should be ready for the nut. Where'd my socket? There's the socket. Get this tightened down a little bit. And you can't let go of the tension you're holding up on this the whole time because everything will get out of place in there. Okay, it's not super tight, but I'm going to kind of work it back and forth a little bit here. I don't hear any crunching, but it's also really hard to tell if everything lined up in there correctly. I think we should be good. Well, I'm a weirdo. I'm going to pop this nut back off and double check. If all the parts in there don't get around the edge of that bushing, it'll just make everything smash and explode as you put it together. Luckily we have a convenient magnet here we can use to pop these out. There we go, one spring washer. Oh, actually, yeah, I can see. Future me, edit this so you can see. You can see the edge of the spacer down there, and it's sticking up, so everything's in place. Perfect. So we'll drop this back in. And this actually won't line up on that center spacer until you start getting tension on the bolt. So it's super important when you start tightening this down to go by hand. And then look down in there. As you turn this, I can actually see it's not quite lined up. So I'll push that over a little bit. There we go. Then we'll tighten just a little bit more. Take a look at it. Yeah, now you can see we're good. There we go. Yeah, this time everything's moving the way it should. Cool. I set the camera on top of this, trying to get it at a high enough angle to look down in there. What happens there, you've got that big threaded rod that's attached to this fork, and then there's that spacer down in there. You tighten this down until everything comes into contact with that spacer, so turning this nut has zero effect on the amount of tension or preload that you have on your swivel. Okay, I get a feeling that rust was actually our friend. This feels a lot looser now. Let's test it. Yep. That is spinning a little bit too freely. Okay, that is now bottomed out. And as you can see, we have free spinning awesomeness. We have that spacer in there that's obviously broken. We have a couple of spring washers that are probably old and are slightly out of spec as far as the amount of springiness they have. So what does all this mean? They don't sell the parts because the roller bearing is pressed onto this shaft. The race is pressed into here, and I don't know, the race might be adhered in there. I don't know if they would use epoxy on something like that, but the way this is all designed, I suppose, even if the parts were available, that roller bearing and its race on the bottom is not really user replaceable. I'm going to look up the parts list. Sunrise Medical has a lot of stuff. I'm going to see if I can find this caster fork assembly and see if it has the bearing on it. I know this whole piece comes as a unit. I don't know if it comes with this or not, or if it's all pre-assembled. Yeah, that's the conundrum. In the world of like mechanical physics or whatever, tapered roller bearings are great. but they got to be in a sealed environment, which this is not. Only thing keeping the water and stuff out is the grease that's in there. So you have to take it apart and clean it, but you can't take it apart to clean it because of this magnet and this sensor. When I screw this back on now and hook this up, this is not going to be in calibration anymore. I could have potentially left the magnet on the stem, then it would be, but when you're pulling this in and out past all those other parts, all those needle bearings are going to pop out of there and stick to this magnet. I mean, it's not impossible to do, but mixed emotions. They were really onto something with this chair, the way it was designed, but they didn't follow through. Now, obviously the 4front 2 exists, so I'm assuming, I haven't seen one of those yet, I'm assuming maybe, I mean, I know they fixed the castor angle sensor problem, that's gone. They're probably using the same bearing setup, which isn't serviceable by users. That's the thing. I really want to like the 4front. There's a lot here that has the how do you even say this? The spirit of this chair, the way it was designed and kind of the base components, I really like where they were going with the design. But they didn't finish it. Even like the shocks and whatnot, the way these are mounted, they are 100% going to start leaking prematurely and fail too soon. This style of shock right here is not designed to be at full extension all the time. When you're sitting on flat level ground, this shock is at full extension. And that means every time you hit a bump, this will go up, compress the shock, and when you come back down to level ground, it's gonna bang against that end stop. And that's what makes them leak. This side doesn't look too bad. The other side, I'll flip this around and show you, but the other side, the rear shock, is leaking badly. So that could have been easily solved by either getting shocks that were maybe a ½ inch longer, so that when you're sitting on flat level ground, they are slightly compressed. Now, there are still circumstances where the shock would, you know, actually technically top out, or bottom out, whatever, but it wouldn't happen nearly as often. The other thing that could be done to fix this is change the bracket link here and basically move this mounting point down this way about a ½ inch, or maybe move this one up, so that when the chair's in a neutral position, it's not at full extension of the shock. I don't know if they fixed that on the new chair or not. Now, over here on the Stretto, you can see they're using the same shocks. See that little golden thing sticking out right there? Now on that chair, sitting on flat level ground, that shock is not at full extension. Thus, it doesn't have the same issues of wearing out prematurely. Actually, let's give this a test real quick. I haven't physically verified that the shocks on this chair, this is a Stretto Edge 3, are not sitting at full extension when the chair is on a level surface. So what we're gonna do, I'm gonna set the camera on the ground, then we're gonna slide this jack under the front of the chair and lift it up. If these front caster wheels stay in the same position and instantly come off the ground when the jack lifts it up, that means they're at full extension. If they droop down a little bit as I lift the chair, that means it's sitting there with a little bit of extension buffered inside that shock. In other words, it's not topped out, which also means it shouldn't wear out as quick. So let's do that real quick. Okay, what you want to keep an eye on is what this caster wheel does when I lift the front of the chair. Ideally, we want to see this thing droop down a little bit, which means there's a little more travel in this front shock. There's the top mount, there's the bottom mount. Just looking at this thing to my eye, it seems like we have a little bit of travel left, but let's actually verify that. Okay, there you go. Did you see that? We got, how much movement was that? Let's point this forward to get a maximum picture of this here. That was what, maybe a ½ inch of travel? That's all it takes to keep these shocks from failing prematurely. Just set it up so they're not sitting at maximum extension when the chair is on flat, level ground. Watch, this will pop back up as I put it on the ground. That's all it takes. Almost nothing. So that's another one of the issues. Then obviously the brakes and all that. If you've watched my the teardown video I did of my old Quantum 4front, I think that video is like almost 90 minutes long maybe. I'll link it up here, but it's called A Look at My Terrible Chair. And I take apart a bunch of this stuff and show it all. But again, the core concepts of this chair I really like. There's just a few things that they didn't figure out correctly. So anyways, enough about the caster swivel bearings. I'm gonna get this put back together. I'm gonna check just to see if it threw itself out of calibration. Then we're gonna move on to the seating and how you adjust the seat pan and whatnot. I have some thoughts about that as well. And actually are shared by the Stretto. So this will be a look at tru-balance 3 seating. I now understand why they have 2 different versions of the seating. There should be one. All of them should be WC19 compliant or occupied transport rated, but they're not. They do 2 versions. And the version on this 4front and the Stretto, tru-balance 3, they are not what I would consider safe in a crash if you're in a vehicle. They may have, well, I'll just wait. I'm gonna get it back together, we're gonna test the calibration, then we're gonna move on to the seating. I have thoughts. Okay, we're sitting in the Stretto here. I got everything put back together and it's back on the floor. Let's see if our calibration is off. Yep. There we go, error 72. I think it's when you get over about 1 mile an hour. Yep. So I put everything back together just like it was, and our calibration is now off. So let's see here. 1.7. So yeah, now we've repaired our own chair, but it's not usable because it has to be plugged into manufacturer authorized computer equipment and have a couple of buttons pressed. Again, I don't think that was intentional, but you know, it's shipped in such a way so that we can't use it. We can't repair it. That drives me insane. So reverse seems okay. Forward. Oh, did it recalibrate itself? Hang on here. Oh, there we go. Yeah. Frustrating. In case you're wondering what the process is like to recalibrate these, let me show you how simple and unnecessary it is. We plug that thing in. Then a few minutes later we get something that looks like this. And press a few buttons here. System, traction control, sensor calibration. And both caster wheels have to be pointing perfectly straight backwards. Like, get out a ruler and measure straight backwards. Then caster sensor calibration. It's going to calibrate the left one. You hit continue. Then it's going to calibrate the right one. Hit continue. And that's it. Now we're done. Now we can drive this thing around at any speed we want after making that repair. And it works fine. We can get all the way up to whatever the maximum speed happens to be, and no big deal. The tools to accomplish that, however, are not available to you and me, and not even available to a lot of dealers. And the ones that might have access don't always understand how to do it. So, I have no words. It is what it is. Once again, QLogic 3, if you have a picture of a house on your controller, that little green button right there, that's how you know you have QLogic 3. And you can't change or program anything. I personally happen to have access to some of the tools because I've got a bunch of awesome lawyers, but it's one of those things. Why? I mean, I understand it. If people are monkeying around with the programming, they can make the chair dangerous. You know, defeating the traction control is a really bad idea unless you never go over, you know, 1 or 2 or 3 miles an hour. But like, not making this stuff available and also refusing to talk to end users about it. Have any of you ever tried to call Quantum? My personal experience and the experience of dozens of other people that have spoken with me that have tried to, they all but hang up on you. The second they find out you're an end user, they are not telling you anything and they want to get you off the phone. So, I really wish I could be a fly on a wall when the day finally comes that the right to repair stuff finally gets to a point to where someone at Quantum or Pride or whatever they call themselves has to say, okay, here's the stuff. That would be glorious. Next up here, I want to take a look at the tru-balance 3 seating and the way you adjust it. So this is going to be exactly the same on the 4front here as it is over there on the Stretto. Now, I've already adjusted the width on this chair. I wound up setting it to 19 inches, which is indicated there. But for example, on the Permobile chairs, the way those work is you pull off the seat pan and there's a series of bolt holes. There's a couple of spreaders on the back on each side and a couple on the front as well. And you pull the bolts out labeled, you know, for the width or length or legs or whatever. And you slide the seating apart and you put them back into different holes. Now that only allows you, I think, about 1 inch of adjustment, since there's only certain holes that you can put the bolts back into. You might be wondering, well, it'd be cool if I could have an infinitely adjustable seat, you know, for width. That's kind of what Quantum's doing here. But if we stop and think about it, if you want infinite adjustability, your bolts are going to have to be sliding in slots. Now, that may not seem, you know, like any sort of problem first off, but you can only get so much clamping load by squeezing 2 pieces of metal together that are riding in a giant open slot. So how does this work? Basically, you've got 4 bolts here in the front. You've got 4 bolts in the back. You don't even have to take the seat pan off. All you do is loosen these. And now all you have to do is grab either side of this thing and pull. And it moves. So you might think, hey, that's actually pretty cool. It's super easy to adjust this seat. I'll zoom in here a little bit and see if I can show you. There's basically a giant slot back here and these bolts squeeze. So you just basically hit this with the hand and it moves back and forth. Let me actually pull this seat pan off and I'll show you what that mechanism looks like underneath there. Now, depending on your seat depth, there's going to be a assorted number of screws you have to remove. Definitely there's going to be 4 here, maybe 6. And because of the seat depth, we have to pull these 4 here, but not these 4 back here, because you can see the seat pan ends right here, and those bolts are behind it. So let's just pull these out as well. These ones are a little bit longer, as you can see. They do have Loctite on them, so that's, you know, something. Then these 2 panels will lift off of here. And now you can see what we're looking at. There's 2 pieces of metal here. There's holes drilled in the top, and there's threads in the bottom. Actually, let's pull this all the way off of here. There, now you can see. It's a weird little sandwich. We've got the center part here with a big open slot. Then we've got this bottom part that has threads. You might be able to see those. You can just barely see the threads down in that bottom half, and they just pass through the top. So basically this just slides on here, top, bottom, middle, drive the bolts through, and it squeezes these 2 together. The problem with this is we have smooth metal surfaces that are painted or powder coated or whatever. You can only get so much clamping load from screws like this. And what that means is this is going to shift around. Maybe not in normal daily use, but for sure, if you're in a vehicle, you know, tied down in a transit bus, something like that, someone bumps into the side of you, your chair bumps into something, these are gonna move. I don't care how tight those bolts are. So it can knock the seating out of adjustment, whatever, no big deal maybe. But what if you're in an accident? This is not gonna hold together. And this scheme of slot adjustment continues. The entire backrest, if you look back here, see how we've got a couple of slots there? That's how the entire back and arm mechanism assembly is held to the chair. It is adjustable like this, so you can adjust your depth, but let me take your arm back and I'll show you that. The point I'm trying to get across here is there shouldn't need to be 2 seating systems. They should make 1, and they should make it occupied transport rated. I use that and WC19 terms kind of interchangeably. They're both the same thing. But that's the problem. Why are we shipping 2 versions of the chairs? And why are we charging a fee to upgrade to the one where you can sit in the chair in a moving vehicle? Who in a rehab chair full time doesn't ride a bus, doesn't ride in a van? What Quantum's expecting you to do is get your chair into a vehicle or a bus, strap it down, and then get out of it and buckle yourself into a seat yourself, or with help or whatever. But the idea is you shouldn't be sitting in the chair, even when it's tied down, in a moving vehicle. That's what I don't understand. Why are there two versions? Like 90% of the other brands out there, or 80%, whatever percentages, everyone else has that included from the factory. It's not an option that you have to pay for. It's not ambiguous. It's not confusing. It's like, yeah, you're gonna be in a moving vehicle in your chair. Why on earth would we not sell it so you can be safe without having to figure out that one, it's an issue, and two, pay for an upgrade? All the other manufacturers are like, that's dumb. We include it. It just makes sense. Here we are at the back. We've got 4 big Allen bolts here. And these basically go through and connect to those slots in the front. So if we loosen these up, which once again, these screws can only have so much clamping force just by the nature of how bolts are. And when you're affixing 2 metal surfaces together that are smooth and don't have any mechanical interface to keep things from sliding, no grooves or notches, or hell, even sanding both of the surfaces so they're rough would be good. But yeah, see, it just moves around. That's the whole chair. That's the arms, the back, joystick. You know, once again, it might be kind of nice to be able to adjust the depth of your seating super easily, but this is why this chair does not have an occupied transport rating, whether it's the ISO version or the WC19 version. There's nothing really other than clamping bolts, which in my book qualifies as hopes and dreams, keeping this whole thing together. So in any sort of crash, your power base is going to be tied down. We've got the tie down just here on the back, and there's some other ones buried up in front where it's really hard to get to them. But all this stuff is going to move around. Force amplification is a thing. You know, shear load is a thing. Now, one could argue they could design this a bit differently to at least meet the ISO standard, and it wouldn't really cost them that much. You know, instead of having these slots that go through, like this, instead of routing it out into a big track, just drill a bunch of holes. That way, even if those are loose, they won't move. It might rock around a tiny bit, but it's not going to forcefully slide. When this gets some force behind it and starts actually sliding, those bolts are the only thing holding it on, and they're being put in load. Well, they're being put under load in a way that bolts are not designed to be strong. This is a shear motion against the threads. These bolts aren't even shoulder bolts of a certain length. They're threaded all the way down. So there's so many things wrong with this when it comes to occupied transport or WC19 compliance and safety. For a chair you're just running around inside your house or maybe outside, probably fine. But Quantum also kind of notoriously has a problem with shipping chairs where the bolts aren't tight. I've seen this on 5 different chairs, 3 of which were brand new, but they were right off the factory floor. And most of the bolts, like here for the tru-balance 3 seating on the armrests, were loose. Most of the bolts down here that connects, actually I haven't even checked these yet. Let's double check those. What size are these things? Is it 6mm? Yeah, see? I got an 1/8 of a turn out of that one. How about this one? That one's pretty tight. Let's try this one. I can't quite get my wrench in there because of the positioning. Let's look at the other side. Okay, that one had some turn. That popping noise is from the anodized metal in the surfaces. That one was tight. I can't get to the back ones. This issue with the bolts being consistently loose on all the brand new chairs, what do I think causes that? So they're really proud of their assembly line where they can pump out a whole bunch of chairs. It's all computerized. They do have humans there doing things, but as far as the actual power tools, from my understanding, like, you know, when they're putting on these bolts that attach the seating to the base, you know, and putting together all of the armrest and seating components and stuff, they have sort of like computerized torque wrenches where they plug them in and they go to an exact torque spec that someone has figured would be adequate, and that's how they do it. When you're tightening things by hand, there's a feel to it. Yeah, there could be a torque spec, but even when you're using a torque wrench, when it clicks into place, you can feel there's a little bit more movement that bolt can travel before it's actually tight. Especially when you have powder coated or anodized or painted surfaces going together. Going a computer controlled amount of torque and saying, okay, that's good. It's not actually torque to the spec that you think the computer is programmed to. So that's the only way I can figure that all of their chairs have, well, the ones I've seen, have consistently loose bolts and fasteners, is because of this electronic system they're using that they're super proud of. Now, sorry, I get animated about this. Well, anyways, I'm preaching to the choir, but yeah, if you've gotten a brand new Quantum and you've gotten out some tools, you're gonna find loose bolts. That's just how it is. So they could spend a little bit more time, probably not even that much more time, probably not even that much more expense to put these seating systems together like Invacare and Amy Systems and Permobil does, and instead of attaching everything to slots, put some bolt holes in. Yeah, it takes a little bit more work to reconfigure the chair, but it's infinitely safer. And even if the bolts are loose on all those other designs, they're still gonna have a bit of strength to them. Granted, the bolts are still not designed for the, horizontal shear load against the side of them. They're designed for clamping force. But even if they're a little bit loose, there are more metal components in there physically keeping them from moving. So, probably fine, but having two versions of every chair that's occupied transport rated or WC19 compliant versus the regular one, how much are they actually saving? Because I got a Quantum 4front brand new. I'm sure a lot of you are aware of that saga. They wound up replacing the entire chair because they shipped me one that was not occupied transport rated. Then they sent me a whole new chair that did have the rating. Funny though, it still had the sticker on it saying it wasn't, but there were a number of differences. And where the seating connected to the power base, they had a couple of extra bars in there. There was a few extra fasteners. And on the back where the seat is, where those slots are, they had some really weird, long all-thread bolts that kind of hooked into the back of the frame. They're not even... Is that plastic? What the hell? But basically, there was some extra bracketry that went around these bolts on each side and came back further, and there's some extra bracketry here. So if those were all loose and this started sliding around, that extra bracketry would catch this mechanism from sliding, in theory, and keep it from moving forward and, under load or the force of a crash, keeping these bolts from shearing off as much. So it was kind of a weird add-on tie wire sort of situation, but even those bolts were loose and they told me that's how they were supposed to be, so I don't know. Moving over to the Stretto here, this chair also has tru-balance 3 seating. The seating system's slightly different because it has the eye level on here and the depth is a little bit further, there's a little bit more depth on this. Also, this one's set to 18 for some reason. I should probably widen that. But if you notice, we have the same sort of slot arrangement here and same back here as well. So this is a tru-balance 3 thing. This is how their basic seating is set up. The odd thing with this one, this chair, I think, has the occupied transport rating. We've got some extra hooks right here. Those are transport brackets, but that's on the seating itself. There's the additional factory ones down there. But seeing that right there, and after looking at the rest of the chair, I don't see the other add-ons. So I can't verify if this chair actually has the WC19 rating or not. It did also come with a DOT-approved belt system, so I'm thinking it does have that rating. My 4front didn't have the eye-level seat lift on it, so the back looked a little bit different. Back here you can see we still have the... Can you see? Let me brighten this up. We still have the slots back here, but interestingly this one doesn't have the extra bracing that my 4front did. Maybe that's irrelevant on a chair with the seat lift or eye level? I'm not quite sure. Hilarious side note, that Stretto, the Edge 3 Stretto, I was able to verify does in fact have the WC19 occupied transport rated package. And the seating is still very similar to that. But you know, to me, for a company that's so proud of the high number or sheer volume of chairs that they're selling, to be proud of something like this, I don't understand the mindset. I don't get it. It's not gonna cost you any extra to do it in a lot, you know, more safe type of method. And let's take all the vehicle equations out of it. Just over time, this is gonna get loose and start getting rattly. And, well, here's another thing. If we look at the seating, we can see that we've got these little adjuster bars here. Then we've got the edge of the seat, which is cantilevered all the way out here. What is holding this up? Sure, you can put bolts through here and clamp this down and this inside part is held in, but that gives you almost no strength for up and down motion on these edges here. Maybe they're working on the theory that putting the seat pan on here adds an additional layer, because if you can tie this point to this point, even though it's only supported here in the middle, well, actually right here on the edge of whatever the width is, the wider it gets, the more cantilevered this is. But if you have the seat pan that's skinned from here to here, in theory, that's going to put tension across that as these edges push down and try to stretch that seat pan. Siri thinks I'm talking to her. So that can make it a little bit stronger, but then you're only using these little screws, and only 4 of them, to hold down that seat pan. And those are clamped in with the same bolts here in the middle, and the seat pan's in 2 halves. So, I don't know. So we got the Edge 3 Stretto, we've got the Quantum 4front 1. We've talked about a few different things here and a lot of my opinions. Are these chairs terrible objectively? I don't think so. There's a lot of things that could be done better, but here's the real question. Would I buy one and daily drive it? Now, both of these chairs were not super expensive for me to obtain. The 4front, again, I really like the chair. I want to like it. I want it to be reliable. I think the main issue with these chairs and this brand, from my experience, is they're not reliable. That's the main issue. When people are using insurance or funding to get their chair, at least in the US, you can only get a new chair every 5 years. If the thing breaks down too much, they're gonna stop fixing it at some point and claim overutilization. That's an insurance billing term. I had that happen on my Invacare years ago because I was going through drive motors, well, mostly gearboxes, about every 8 months. And they determined that I was doing something incorrect because it needed that much repair. There's a lot of other brands of chairs that can last 5 years easily, even with minimal maintenance, sometimes not even changing bearings and whatnot. In the case of the 4front here, there is mandatory maintenance on those castor swivel bearings. We haven't taken apart the motors, we haven't looked at the gearbox, we haven't looked at the brakes on these yet. We are gonna do that at some point. Not today, this video is already getting pretty long. But there's just a number of objective things you can point at, and any reasonable person that's had any experience with any sort of mechanics or repair or anything like that can look at it and they're all gonna say the same thing. Yeah, that needs maintenance. If nothing else breaks and it's only maintenance, that to me, in this application with a wheelchair, is not an ideal scenario. Everyone else uses sealed roller bearings and they're fine. They do wear out, but it's not something where you can set a clock basically and say, this has to be taken apart and cleaned, you know, at this exact interval. Sealed roller bearings are not, you know, the end-all be-all of everything, and they can wear out and they are susceptible to water. The rubber seals are not 100% watertight, but just looking at that one aspect for maintenance, these chairs are gonna be much less desirable, you know, to me, because I'm gonna have to buy parts. Even if I was able to source those bearings, I don't have the equipment here to press those on and off. And Quantum doesn't even sell the other parts separately. You have to buy an entire assembly. Even if your chair is funded, you likely have a copay. So that's gonna cost you money. Now, the Edge 3 Stretto, just from my brief playing around with it and looking at it, to my eye, seems like it's a chair that was designed to exist. And it was actually designed and built and brought to market in a much more complete fashion than the 4front 1 was. It was designed and built, they thought through most of the things, and it appears to be a complete product just to my eye. The 4front was, and this gets a little bit into the weeds, we don't really know where that power base came from. There were some acquisitions of companies and whatnot, and I'm not saying they got it from one place or another. I said that once before and everyone freaked out. But they basically took a power base that basically existed and put their seating on it and kind of tied everything together. That can be done, you know, properly, but even on the Stretto, a chair that I like, that tru-balance 3 seating system, even though this one I think has the WC19 rating, it doesn't seem right to me. But again, I'm just a random guy, and those are my thoughts. Based on all the other stuff I've seen in here, there are not any chairs anywhere in here, including this Group 2 like bariatric scooter chair here, one that's designed for a 350, 400 pound person, that has a plywood seat back covered in foam and vinyl and a plywood seat base. That thing is more structurally sound than the slot system they use to adjust these. You can look up in the Pocket Ref or any other, you know, online manuals or printed books. You can find the size of the bolt, you can find their diameter, their length, and their thread pitch, and you can objectively look up the amount of clamping force and then cross-reference that with the amount of weight that's in the system, the amount of shear and, you know, basically moment arm force. That's not the right term for that, but you can look up all these numbers and you can see objectively that putting a few of those, what are those bolts with the spikes that go into plywood? Putting a few of those into a 1 inch or 3/4 inch piece of plywood has way more shear strength than this. Again, should you completely avoid the chair? Meh. You know, if you run around inside and you don't go outdoors a lot, you don't ride in a vehicle, you know, and there's a fair number of people that do that. There's nothing wrong with that. It'll probably be fine. You know, it's just, let's liken it to the Volkswagen Beetle. It's an okay car. There's a cult following with those. But you gotta get out and adjust the valves, and you gotta do it every 5,000 miles or something like that. You can rebuild the entire engine in an afternoon or on the side of the road. So it's not really that big of a deal. It's not that much expense. It doesn't take that much time. But we're dealing with a group of people here that already have enough problems. They have mobility issues, they have other health issues, they're dealing with caregivers and housing and all the other things. Why on earth would you take any of those trade-offs to get a chair that is gonna require any more effort or work or expense than something that's equivalently priced and you don't have to worry about all that? That's my thought here. Think of your market when you're designing something. And I understand that, you know, prototype manufacturing is a thing. If you've got a product that's really, really good, but it takes an extra 17 hours to put together because it's designed a certain way, yeah, by all means redesign it a little bit so that the manufacturing process makes sense and you don't go bankrupt simply trying to build the things. There's a lot of balances with all that. But, you know, again, to people that are using actual rehab chairs full-time, I can't recommend that thing. It just doesn't make sense. And that's just the logical, any random person on the street, you know, buy a BMW versus a brand new Kia or something. You know, one of them's gonna cost more to own. Yeah, one might seem a little cooler and, you know, whatever else, but it just, yeah, you gotta factor in everything and then make your decision based on that. I'm sitting in this 2021 Permobil F3. I've had a lot of Permobiles over the years. I've never had any of them leave me stranded, well, through the fault of the chair. I've done a lot of dumb stuff. I had an old C300 that I modified the seating on. Actually, the current backup chair that I have is a C300. I've modified the seating on that, and you know, it's broken as a result of that. But leaving them completely stock and not screwing with them, I've never had any failures. Now, is every single one gonna be perfect? No. You know, I've had a lot of problems with quantums. I know of a lot of other people that have had problems with quantums, but then there's also a lot of people that have had issues with Permobil. So a lot of times it's kind of luck of the draw, but things seem to skew in a way overall as a whole that, you know, Permobil, Amy Systems, Bounder, they all seem to be repeatably more reliable in more people's circumstances and, you know, the sheer numbers of them that are out there still functioning without major repairs than anything that starts with a Q. I might extend that into quickie in some cases too, but that's a whole different thing. So anyways, let me know your thoughts. And you know, if you have a Quantum and it works great for you, no problems with that whatsoever. Get the equipment that works for you in your situation. And you know, I've talked to a couple people in the comments section that have had 4front ones, like the first version of them. They haven't had any issues. They haven't even had to have the motors replaced and have no problems with the brakes holding it on a hill. We haven't tested it on this one yet. But, you know, so that's the thing. It's not all or nothing. It's just you look at an entire average of everything as a whole. There's always outliers. I don't care what you're talking about, what brand, what product, anything. There's always outliers. So you can't base it on, you know, one or two extreme scenarios. You got to look at everything as a whole. And also remember that a lot of people aren't going to say anything unless they have problems. So there's some wheelchair review websites you can look up any brand, pick it. Amy Systems, Bounder, Permobil, Quantum. You're only going to find, by and large, people that have problems complaining. You're not going to hear about the people that have no problems whatsoever and are happy with it. You know, it's like that saying where, you know, how many thousands of airline flights take off and land successfully every day? You only hear about the ones that have problems. So, something else to consider. Anyways, hopefully you enjoyed this. Leave your thoughts or comments down below. Tell me about the chair you have. If you have a Quantum, you know, and you haven't had any problems with it, please let us know. If you have one and it's been a nightmare, kind of like my 4front was, let us know the things that have been replaced. Once again, the reason I kind of started leaning into this channel and, you know, I think we've got a pretty good community here, people and experiences and whatnot. So discuss it down below. Let's all share our thoughts and, you know, hopefully we can advise people in the future that are looking for brand new chairs, newly injured people or people that are looking for replacements and whatnot. And yeah, thanks for watching.